Hi everyone, in this video we're going to go through 3E, question 3, so I probably should write that up the top. So these are questions from 3E. So in 3E we're determining transformations, and what is kind of different with question 3 is we're going backwards. So we're used to seeing going from, quite your basic graph. So here we've got a trunker, so y equals 1 over x squared. And usually we would go to a transformed graph. Okay, but here we've got the transformations already happened and we want to go back to its original. And when I say original, it's not always going to be a basic graph like 1 over x squared, but just to make things kind of simpler, I'm going to use that sort of language. So if you can see this first one here, we've got y equals 5 over x minus 3 squared minus 7. So from that, we could easily tell what the transformations are if we were going in that direction, if we were going from your basic truncus and then having those transformations applied. So knowing, we go in the order DRT, so we do our dilations first. So I can see we've had a dilation of 5 from the x-axis. We've been translated 3 units in the positive direction. And I might actually write these down along the x-axis. Whoops. Let me just get the right. Oh, so temperamental. Okay, so we've had a dilation. Now, this is not the answer. I'm just saying if we were going from the basic to the other one. Dilation. Oh, I should say dilated. But I'm not doing too well this morning. Dilated by a factor of 5 from the x-axis. All right, so there's our dilation. There hasn't been any reflections, but we've had 2 translations. So we've gone 3 units to the right, just basic language, but that's the positive direction of your x-axis, and 7 units down. Now, if we were to go the other direction, okay, so what this question is saying, we're going the other direction, so we're going to the transformed back to the basic, then basically it's the same transformations but in reverse. So instead of having DRT, all right, we do our translations first and then your reflections and your dilations. So what I mean by the opposite, so if we were going 7 units down, we would go 7 units up. If we're going 3 units to the right, to go back, we would go 3 units to the left. And then our dilation factor, well, it's been a factor of 5, so the inverse of that is 1/5. So it's been dilated by a factor of 1/5 from the x-axis. Now, you can do it that way. All right, that's just assuming that you've gone from something that is that's already been transformed to something basic. If you have a look at question E, not so much the case. So you can do mapping. So mapping will always work. So I'm going to do question 3A using mapping. And then we'll have a look at question C and then we'll do question E. All right, so when we're doing mapping, so I'm just going to write the question here. So we're doing question A. We're going from y equals 5 over x minus 3 squared minus 7. And that's being mapped to. So I'm just going to do the image of y and the image of x squared. All right, with our equation here, we just need to rearrange it, all right, to get it into its kind of basic form. So if we have a look on the right, all right, what I mean by basic form is just 1 over x. So I'm bringing that 7 over first, so 1 plus 7, sorry, y plus 7, not 1. And then I'm going to get rid of that 5, so I'm going to divide both sides by 5. Oh gosh, sorry guys. Really need to reduce the size of that eraser too. That should be 1 over. God, not focusing this morning. All right, and just so I can see that dilation factor clearly, I'm just going to, instead of doing over 5, that's the same as 1/5 times y plus 7. All right, so now my y, my image of y is equal to 1/5 y plus 7, and my image of x is x minus 3. So we can see there our transformation. So we've got this dilation factor here, and what was I talking about? That translation, and we've got this translation here. Now just remember, we do have to do it in the order TRD. So we don't say the dilation first, we say the translation. So just to be consistent, we can see we've gone up 7. What I mean by consistent with what I've written here. Up 7 units. Other translation has gone to the left 3 units. And we've had a dilation factor of 1/5 from the x-axis. So always make sure you say which axis it's come from, otherwise you won't get the mark. Okay, so you can see, you can do it by mapping, or you can just think, okay, well, I'm doing the opposite. So if I was going the original direction, sorry, that what I mean by original, we were going from here to here. All right, I showed you those transformations. So we're going from a transformed function or graph to its basically undoing it. All right, so let's have a look at question C. Can I got enough space down here? No, just got to remember what they are. Oh gosh, it's a long one. -3, 3x plus 1. Squared plus 7. Okay, so if you wanted to, you can read all the transformations that have happened here, but as you can see, it's getting quite complex, so it's probably easier just to do your mapping. Okay, so let's transform this first one, or transpose, I should say. So I'm going to bring that 7 over. You could probably do this in more than one step. Bring that -3 over, so y minus 7, and I am going to, instead of dividing it, I'm just going to be -1/3. Okay, so we can easily see the dilation factor. All right, and we can just leave it like that. Now you're transformed, we've got y dash equals x dash squared, so my y dash is equal to, whoops, -1/3. Y minus 7, and my x dash is equal to 3x plus 1. All right, so when we're looking, remember we go going the opposite direction, so we're going to do our translations first. All right, so we've gone down 7. We're going to the right. We've been reflected along the x-axis, and that's because we've got that, oops, got the x, got this negative here, and then we can do our dilation. So dilated by a factor of 1/3 from the x-axis, and dilated by a factor of 3 from the y-axis. All right, so just highlighting them. Oops. All right, so the reflection comes from this negative. All right, this 1/3 is here, and then this 3 comes from here. All right, I've just double checked with the solutions, and I did notice that in the textbook solutions you might be thinking, oh, they're slightly different. They've continued with the DRT. The reason why I didn't, because I wanted you to see, well, we're just basically doing the opposite. Now, let's have a look at, I'll do question C and I'll show you the solutions. All right, so we're looking at question C, which you can see. Let me make it a bit bigger. All right, you can see they've gone in the, well, they've done the reflection first, but reflected in the x-axis, dilation factor of 1/3 from the x-axis, and then our translation is different here, so 7/3 units up, dilation factor of 3 from the y-axis, and translation 3 units to the right. So if we go back to here, our shift down, we had 7, and that all has to do with the order. Now, if we wanted to stick to DRT, all we need to do is have a look at this, and we're just basically going to expand that. So if I was to expand that, I would get -1/3 y plus 7/3. So there you can see, all right, our reflection again, we've got the same dilation, but instead of going down 7 units, we're going up 7/3. So it's the same graph. All right, you're just saying the translations differently. That's why it's always important to get the order correct. So if you always want to stick to DRT, all right, which you can, just make sure you do expand those brackets, okay? Because I didn't expand, that's why we did it the other way around. All right, I know it can be so confusing, but the reason why I did translations first is because, remember from the very beginning when I did this to show you that it's the opposite, it kind of, I feel, makes sense doing it that way. All right, let's have a look at question E, and I might have to write this down. Okay. Oh, I thought I'd add another page. Okay, sorry guys. Let me just quickly add a page. This always screws things up when I add a new page in. There we go. Just going to put it up here. All right. Let's write it down. So we're going to do 3E, question 3E. All right, so we're going from y equals 2 times the square root of 4 minus x plus 3, and we're going to y equals -root x plus 6. So very different to the other ones because we're not going to a basic graph. All right, so we can still use mapping. So mapping will work every time. All right, so let's just rewrite this. So y minus 3 equals 2, 4 minus x. So getting rid of that 2, so the inverse is multiplying by half. You can divide by 2, but seeing as multiplying by half is just easier to see what that dilation factor is. And we can keep what is underneath the square root sign as 4 minus x, or you can, if you are doing DRT, you do need to just change that to negative. Whoops, let me just, really need to get rid of that big eraser. All right, so taking that out, there we go. All right, and then our image, all right, so I am just going to bring that 6 over, and then that negative. All right, so the x is easy to see. And I might do the y over here. All right, so just getting y dash on its own. Takes a bit of time. That's at plus 6. All right. Oh, so we can expand our brackets. Oh, hold on. I didn't get rid of that 6. All right, so if we're getting rid of our brackets, so we can do DRT. And I've got fractions there, so I do need to add the 3 onto to 6. Now, not a hard one to do, but I'm just showing you here. Just have the same denominator. So we get -half y and then 15 onto. All right, and I'm just going to expand the brackets here as well. So I probably didn't need to transpose it before. Anyway, all right, so we are going to do DRT, all right, because I got rid of those brackets because that's what we're used to with mapping or reading our transformation. So doing our dilations first. So this half, let me just highlight what I'm talking about. So we've got this half here, there's a dilation factor. All right, so it's been dilated by a factor of 1/2 from the x-axis. All right, then we've had 2 reflections. So it's been reflected in the x-axis and reflected in the y-axis. All right, so just that's coming from this negative and this negative here. And we now have our translation. So it's translated to the right 4 units and translated up 15 on 2 units. Now, if you kept your, let me just highlight it in a different color. If you kept, oops, what are you doing? Where am I? If you kept it here and here, all right, you would read the translations first. Okay, when you're expanded, we're reading it in DRT. All right, and I've just read the solutions. Okay, so again, it's done the reflection first before the dilation. So it's the same thing, and the dilation factor here wouldn't affect the transformations before it. So yeah, the order is still the same, but it's done the transformations here first. All right, so if we go back here, reflected in the y-axis and then 4 units to the right, and then it's done the transformations for the image of y. Okay, oh my gosh, that is exhausting. So if we go back up just to, whoops, which is down. All right, if you're going back to a very basic one like we did here, it's very easy. It's just the opposite. But as you can see in E, mapping is just going to help you. Just remember, if you want to stick with DRT, that we do just need to expand those brackets. Otherwise, you can keep it in bracket form, like I've highlighted here in purple. But you would just read the transformations differently. All right, bye.